This video is about the first step of energy obtention in cells, which, as I think that you remember by now, is glycolysis. Glycolysis is a word composed of two Greek roots, glykos, sugar, and lysis, breaking down. Glycolysis means literally breaking down sugar. Why do we need to break down sugar? Straightforward, because the sugar molecule is too complex. Sugar molecules are normally, more than normally, exoses. So what is an exose? An exose is a molecule that has 5 carbons, and that is kind of difficult to process for our mitochondria. So, in general terms and in general ways, I use here the term exose to indicate that it is any type of sugar that has 6 carbons. Hexa 6 O's structure. Exose, okay? It's molecule. Sorry, I was going to use protein, but so it's any kind of molecule that has 6 carbons in structure. So exose by extension can be sucrose, saccharose, saccharose, galactose, sugars aplenty. Now, the first process is phosphorylation. What is phosphorylation? In chemistry, phosphorylation is any process in which you add or subtract phosphate. Got it? Why is phosphate important? ATP, that P is from phosphate, so it's kind of important. Second part, lysis, breaking down, the physical process of breaking down an exose into 2 smaller molecules of 3 carbons. And the third part is oxidation. Oxidation is actually important in the way that we're going to obtain ATP from this, but this is not the objective. The objective of glycolysis is not the obtention of ATP per se. It happens, happy accidents, but is not the objective. So I'm just going to refer to our diagram here. So we have glycolysis here. So we have an exose here. I just use the general term exose because this, as I told you, can be any kind of sugar that has 6 carbons. Now, I am going to use 2 ATP. What for? To initiate the process of phosphorylation. I need to use 2 ATPs because, as you may know from chemistry, chemical reactions very often, if not never, happen like by accident, like, oh, it happened. You need to initiate these reactions. And how does our body initiate the reactions? By spending a little bit of energy in this. But relax, we're not going to spend energy because in the end you're going to see it, we are not going to really spend it. So we take 2 ATPs, activate the reaction. Now we have 2 ADPs, adenosine diphosphate. This is important. You go from ATP 3 to ADP 2. You got it? So that exose has been phosphorylated, and now I have exose biphosphate. Exactly. Bi to phosphate, phosphates. If you notice, I have here and here. Where do I get these phosphates from? 2 ATPs provide 2 phosphates. Now one goes here, one goes here. So far, so good? Cool. Now I have our exose biphosphate. I need to break this down. How do I break it down? Our body uses enzymes to do this process, but I'm not going to go there because we're going to have a lesson specifically for this. So the lysis process produces 2 triose biphosphate molecules. Why I change from exose to triose? Simple. I have a 6 carbon sugar, now I have a 3 carbon sugar, triose biphosphate. Now, and this is important because it's actually pretty cool. Look what happens. I have my 3 carbons, my 3 carbon sugar with phosphate, each one of them. I add ADP. You see it? You see the ADP here? This is super cool. I have the phosphate, and this phosphate will get to here. And then I get ATP. But Mr. Chris, I only have 2 of these molecules. Yes, but I'm not going to use 2 of these. I'm going to use several of these. So I'm just going to have this. And also I have 2 NAD. What is NAD? NAD is an electron acceptor. It's an enzyme that actually carries hydrogen away. And we are going to use this up in the future. So I have my 2 NADs. And they come here and they grab this hydrogen and leave 2 NADH plus H. Clear? Remember, I have phosphate here. Now, after oxidation, I have no phosphate here. I extracted the phosphate to create ATP. But Mr. Chris, why I still don't understand why I have 2 of, I don't get it. Remember that we have 2 of these. This is like, if this arrow here is like if I bifurcate this. So I'm just going to have 1 for each. So, in the end I will have 2 3-carbon sugar, but I'm not going to call it triols. I could, but since it's a very important molecule, I baptize it, well, not I, the person who described it, as pyruvate. In some books you find it pyruvate, but it's basically the same, so no big deal. The whole glycolysis series of reactions is called the Embden-Meyerhof pathway. What is a pathway is when you start some here and you go through a series of reactions and end up here. So this is a pathway, okay? A metabolic pathway. It's the EMP, Embden-Meyerhof pathway. So, see you next time. Bye.